Hi everybody, my name is Professor Rad, and today we're going to solve some equations. So let's start out with a couple of definitions which are going to help us build our techniques for solving equations. And then we'll work through a few examples of applying just a single technique one at a time. So let's start with our definition. An equation is a statement that one algebraic expression is equal to another. So we actually saw some equations when we saw formulas. So like P equals 2L plus 2W. That's an equation because you have one algebraic expression P equal to another one, 2L plus 2W. Now, when we're solving an equation, the addition property says that you can add or subtract the same amount from both sides of an equation. Now, the addition property is called the addition property because subtraction is really addition of the additive inverse. So subtraction and addition are kind of the same thing when you involve negative numbers. So that's why it's just called the addition property instead of the addition and subtraction property. So similarly, the multiplication property says that you can multiply or divide both sides of an equation by the same non-zero number. Now, for the multiplication property, we're going to specify non-zero because 1, you can't divide by 0, and 2, if you multiply by 0, you're basically erasing all information because anything times 0 is 0. So multiplying by 0 is not going to be helpful for us. When we go to solve an equation, the way that I like to think about it is like Libra, like thinking of it like scales. And so an equation is a statement that like the two sides of the scale are in balance with each other. And if you add a pound to one side, if you want to keep things in balance, you add a pound to the other side. That's what the addition property is saying, that if you add the same thing to both sides, or if you take the same amount away from both sides, you're still equal, right? You're still maintaining the balance. And similarly, if you double the amount on each side, or you cut the amount on each side in half, the multiplication property says that you're still maintaining that balance. So let's go ahead and apply these properties to help us solve. First, they want us to figure out whether we should add, subtract, multiply, or divide in order to solve. Then we're going to solve the equation, and then we're going to check our answer. So there's 3 things that we're doing here. The goal in applying the addition or multiplication property is to basically solving an equation is like the opposite of evaluating an expression. You're like undoing operations. So our goal when we apply these properties is we want to apply a property that will undo whatever operation is being performed to the variable. What I mean by that is, for example, here, 3x, I have x being multiplied by 3. I want to get x by itself because I want to know what x is equal to. So maybe x is equal to 7 or x is equal to 2. So what I want to do is I want to undo this multiplication of 3. So to undo multiplication, we're going to divide. Okay, so for this question, we're going to divide in order to solve. I'm going to divide by that 3. Now the reason this works is because 3 divided by 3 is 1, so it cancels out, and I have just 1x left on the left. On the right-hand side, hello friend, I'm going to do 42 divided by 3 to get 14. And the two sides are going to be equal because we divided by the same amount. Now, to check our answer, we're going to go back to the original equation, and we're going to substitute in this answer we found to see if it's true. So I'm going to say 3 times 14 Does that equal 42? Does it? 3 times 14. Yes, we get 42. So both sides of this equation end up being 42. So it works out. We can check our answer. Let's go ahead and try another question. So here I have 3 plus x is 42. So now, instead of the 3 and the x being multiplied, they're being added. So to get x by itself, I want to undo that addition of the 3. So I'm going to subtract 3 from both sides of the equal sign. So when we say both sides, we mean I'm subtracting it from the right-hand side of the equals and also from the left-hand side of the equals. The reason that this works is because 3 minus 3 is 0, and 0 plus anything is the anything. So those are going to cancel out, leaving me with just an x on the left. And I can count down this one. 42 minus 3 would be 41, 40, 39. Oh, and I forgot to write, we were going to subtract to solve. So for my check, our equation is 3 plus x equals 42. So I'm going to substitute 39 in for x and see if we get a true statement. So 39 plus 3, 39, 40, 41, 42 is indeed equal to 42. All right, let's work through a couple more problems. Okay, this time in this equation, I have x minus 15 is equal to 2. So it looks like the 15 is being subtracted from the x. So in order to solve this, I want to do the opposite. So instead of subtracting 15, I'm going to add 15 to both sides of my scale. So I'm going to add. So I'm going to add 15 and 15. The negative 15 and the plus 15 are going to cancel each other out, and that gives me an x on the left. And then 15 plus 2 is 17. You can also think about this equation, x minus 15 equaling 2. You could also think of this as asking the question, what number minus 15 is going to give you 2? So one way to do that would be, what number minus 15 is 2? Well, 15 plus 2 is 17. So 17 minus 2, or 17 minus 15 should give me that 2. Okay? That's essentially what we're doing in this process. Let's do a check. So we have x minus 15 is equal to 2. So we're going to substitute that 17 in. I do get 2 when I subtract. So it looks good. All right, and let's do the last one together as well. Now, part D kind of looks awful because it looks like we have a fraction, right? But remember, fractions are another way of dividing things up. So you could also think of this as x divided by 15 is 2. So if you don't like that fraction bar, you can treat it like a division problem. And now we're going to say, well, what's the opposite of dividing, right? If x is being divided by 15, I want to undo that division so I can multiply. If I divide by 15 and multiply by 15, they're going to cancel each other out, and I'm going to be left with just that x. Then 2 times 15 is going to be 30. So x is 30. So one of the reasons that division tends to be written this way in an equation is so that you can do the multiplication kind of right on the side here and get the canceling a little bit more smoothly, I guess. So this is another way we could have shown our work for this. Oh gosh, excuse me. And I forgot to say, we're going to multiply. All right, so let's do our check. So x over 15 is equal to 2. So is 30 over 15 equal to 2? Let's use our friend here. So you could either do 30 divided by 15, or use your fraction button, 30 over 15, and we get 2. So it does check out. Okay. Now, in each of these instances, when we did our check, we did the problem correctly, so it worked out. But what does it look like when a check doesn't work? Okay. So I have an example of some work here. This person did 3 plus x equals 42, and then they added 3 to both sides and got 45. So let's check their work here. The original equation was 3 plus x equals 42, and they got 45 as an answer. So 3 plus 45, does that equal 42? Well, 45 plus 3 is 48. That does not equal 42. So when you do a check, if your answer is wrong, you get a statement that doesn't make sense. So 2 things to check. If you get something like this, first check your check. So did I do this addition correctly? Did I sub in properly? I did. So now what this is telling me is to go back and look at my work and see what I might have done wrong. In this case, it looks like I was adding 3, and since the x and the 3 were being added, I should have subtracted this 3 instead. So then I would go ahead and I would make that correction to my work. So we have a few Now You Try problems for you to work out on your own. In the next video, we're going to start looking at equations that have more than one step. So all of these equations, they just took one step to complete. In the next video, we're going to be looking at equations that take 2 or 3 or more steps in order to be able to solve. So I'm looking forward to seeing you then. In the meantime, have a wonderful day.